All right, so let's talk about this lesson, which is the medians of a triangle. So during proofs, we actually learned the definition and what a median is. It is actually important, again, in the concept of similarity. So let's talk about it. So remember, the median of a triangle connects to the midpoint of the opposite side. So in exercise one, three triangles are shown below with midpoints of each triangle located. We want to draw all the medians. So as you guys can see, there's points on each side. So essentially the median goes from the vertex of the triangle to the midpoint of the opposite side. So let's take a look at this first triangle. So the point is here. So one median in this triangle is this one. Now, this midpoint connects to this vertex like that. And then there's another midpoint on this side, which gets drawn here. Okay. This triangle, so the midpoint is here. So this one gets drawn like that. This one gets drawn like that. And then this one gets drawn like this. Okay. And then the last one, so that one looks like that. That one looks like that. And then this one looks like that. Okay. All right, so for exercise 2, they're asking us what is true about three medians of a triangle. So the medians of a triangle intersect at a common point. So this kind of, if you want to get really technical, so medians are what we call cocurrent. Okay. All right, so let's take a look at exercise 3. So in the triangle below, midpoints D and E of sides AB and AC have been connected to vertices B and C from medians CD and BE, which intersect at F. Now, A, what are two ways that DE and BC are related? So we know that since D is the midpoint of AB and E is the midpoint of AC, DE is the mid segment of this triangle. So we know the mid segment is 1/2 the length. So DE is 1/2 the length of BC. DE is 1/2 the length of BC, and DE is parallel to BC. Okay. Now, since these two lines are parallel, so we have to make an argument for why these two triangles are similar. So since these are parallel, this angle is congruent to that angle, and then that angle is congruent to that angle because they are alternate interior angles. So by angle similarity, so since DE is parallel to BC, we know that angle DEF is congruent to angle FBC, and angle EDF is congruent to angle FCB. Okay. All right, so now we have to prove that BF is equal to twice the length of FE, and likewise CF is equal to twice the length of FD. So since these two triangles are similar, we know that their sides are proportional. Okay, so we know that the length of BF over FE is equal to CF over FD, and that's also equal to BC over DE. Okay. Now, since the length of DE, where are you? Somewhere over here. Oh, well, twice the length of DE is equal to BC. So twice the length of DE is equal to BC. That's going to tell us that BC over DE is equal to 2. The ratio is equal to 2. Okay. Now that's also going to mean that CF over FD is also going to be equal to 2. Now, when we cross multiply, we get 2 times the length of FD is equal to CF. Same thing with BF and FE. If we have BF over FE, that's also equal to 2. So when we cross multiply, we end up with BF is equal to twice the length of FE. All right, so this is going to lead us into the medians of the triangle theorem, whatever you want to call it, relationship. So the three medians of a triangle concurrently intersect and partition or divide each other in a ratio of 2 to 1. Okay, so say I had a triangle ABC, and I have median here, or some medians. Let's call this point D, and we'll call this point E. Okay, the ratio of the length of AD to DE is going to be 2 to 1. Okay. All right, so let's look at exercise 4, and we'll take a look at an example showing this with like numbers and action. Okay. So in triangle DEF shown below, the midpoints of sides DE and EF are marked G and H respectively. The segments FG and DH intersect at J. So if JH is equal to 8, FG, this whole thing, is equal to 18, then we want to find some lengths. All right. So let's first start with the length of DJ. Now the length of DJ and JH is 2 to 1. Okay, so the length of DJ is equal to twice the length of JH. Now JH is 8. So the length of DJ is 8 times 2. So 8 times 2 is 16. So the length of DJ is equal to 16. All right. Now we want to find the length of DH. Well, the length of DH is equal to the length of DJ plus the length of JH. So 16 plus 8 is equal to 24. All right. All right, so now let's take a look at FJ. Now we want to find this one. Now here's the thing, the length of FJ to JG is 2 to 1. All right, but we were given that the length of FG is equal to 18. Okay, now this is going to be really weird, but the length of FG is going to be the length of JG, let's call this X, plus the length of FG. So the length of FG is twice the length of JG. So we're going to do 2x. Okay. Now we just said the length of FG is 18. Okay, so we have 18 is equal to 3x, so x is going to equal 6. So the length, however, we're not done yet, so we need to find the length of FJ. So FJ is twice the length of JG. So the length of FJ is equal to 12. Okay. All right, so let's take a look. We're going to take a look at how to construct a median in a triangle. Now, before we get into the median construction, let's review the construction of a perpendicular bisector. Okay. I feel like we talked about this briefly, maybe, possibly, I don't know, but let's review it anyways. So the perpendicular bisector is how we find the midpoint of a segment. So what we're going to do is we're going to take our compass. Now, your compass for the perpendicular bisector construction needs to be at least halfway the length of this entire segment. It can be all the way, but it needs to be at least half. All right, so I'm going to make it a little more than half, maybe about 3/4 of the way. And what I'm going to do is I'm going to draw a half circle in one direction, like that. Okay, now I'm not going to change the length, but I am going to put the compass point on the other end point. I'm going to do the exact same thing here. Okay. Now I'm going to take my straight edge. I'm going to draw a line like that. Now this point right here, that is the midpoint. All right. Now, so for exercise 6, now we actually want to find where all three medians of the triangle intersect. So to find this point, we need to draw the medians of construct at least 2 of the medians. Now, the medians pass through the midpoint or connect to the midpoint of 2 sides of the triangle. So what we need to first do is the perpendicular bisectors of at least 2 sides. Okay. And then we're going to draw in the median. All right, so let's start. So I'm going to do the perpendicular. Now you can do any 2 sides you wish. I'm going to start with the length of BC. Okay. So we're going to do the perpendicular bisector. So the exact same construction we did here in this question. Okay. Now I'm going to draw in the median. No, I'm going to draw, I'm going to draw in the perpendicular bisector of this. And that is quite off. Hold on. Let's try this again. I think that's going to be better. Yeah. There we go. All right. Okay, so now we're going to draw in the median here. Okay, so there's one median. All right, so now we need to do the perpendicular bisector of another side. So I'm going to do the perpendicular bisector of AB. Okay. Now here's the midpoint. So the median drawn from point C to this other midpoint across from it. So this point right here is point P. Okay, so this is where the medians should intersect. All right.